Hello students, in this video we'll see how to use reduction of order to solve a two-dimensional linear system that has repeated eigenvalues. Let's consider the system R prime of t is the matrix 2, -1, 1, 4 R of t. We know the solution of this problem can be written as R of t is the exponential of the matrix A t applied to R0. In order to find the exponential of AT, we need to find the eigenvalues and eigenvectors of this matrix. So we'll consider the characteristic equation. Which will be 2 minus lambda, 4 minus lambda, plus 1 equals 0. If we expand this out, we will have a lambda squared. Then I'll have a -6 lambda. And then I'll have a +8 and a +1. That'll be a +9. And we'll set this equal to 0. This is a perfect square. This is lambda minus 3 quantity squared equals 0. So in this case, we only have one eigenvalue. Lambda equals 3 is the only eigenvalue. Which means we won't have enough eigenvectors to form the PDP inverse diagonalization. What we'll do instead is we'll solve the problem by reduction of order. So we'll consider the solution R of t, which is A of t, B of t. So I will vary my eigenvector, e to the eigenvalue t. So this is reduction of order. And our goal is to find A of t and B of t. So to do that, we'll plug it back into the original equation and check. So I will have R prime of t will be A prime of t, B prime of t, e to the 3t, plus 3 A of t, B of t, e to the 3t. That's the left-hand side of the equation. The right-hand side of the equation, A of R of t, we can see will be 2 A of t minus B of t, and then A of t plus 4B of t, e to the 3t. And now we see that these two vectors have to be equal, which implies that A prime of t plus 3A of t is equal to 2A of t minus B of t from the first entry of my vector. The second entry of my vector will tell me that B prime of t plus 3B of t is equal to A of t plus 4B of t. I can simplify these to say that they're exactly equivalent to A prime of t is equal to -A of t minus B of t, and B prime of t is equal to A of t and then plus B of t. And so now we look at these equations, and there will always be a linear relationship between these equations if there's a repeated eigenvalue. This tells me that A prime of t is -B of t prime. Now these two functions have the same derivative, so they must differ by a constant. So if I integrate this equation, I will have that A of t plus B of t is a constant c. Since I know that A of t plus B of t is c, I can fill it into this equation for B prime. That will tell me that B prime of t is equal to c, or B of t is equal to ct plus another constant d by integration. I now know B, so I can use that information to find A, since A is c minus B. So A of t is C minus B of t. And C minus B of t will be C minus D minus CT. So I have now found A of t, and I found B of t, so I can write down our solution. So the solution to our problem R of t, so our solution R of t will be A of t, which we found to be C minus D minus CT, and B, which we found to be CT plus D e to the 3t. And I see that my problem, I have C and D, which are constants, so I have two arbitrary constants, so this in fact is the general solution to my problem. Thank you very much.